afternoon. This is a session on just kind of where we are with ACPI on the server side and what's going on there. I would ask that all sharp objects be left outside the room, and only small Nerf balls and things like that are allowed to be thrown. Okay, so yes, I'm looking at you, Mark, and you too will. So. So just kind of where are we with things? What we'll try to do is we'll try to go through, which one? Oh, yeah, okay. Someday I'll learn how to use a computer. Okay, so here's just kind of the basic topics that we'll go through, just sort of where we are with the core set of patches, where we are with the GIC v3 patches and the things involved around it, SMMU, NMU, just a brief recap of power management and what's going on there. If you saw Ashwin's presentation yesterday, you've probably seen all of that stuff already. We'll talk a little bit about what we're doing with LoveOS and the firmware test suite and how that's actually being used to verify that ACPI is behaving the way it should behave. And then just a brief walkthrough of a to-do list that we have of all of the various and sundry things that we need to address that are not solely technological, but are some, just some social engineering, some is some technical engineering, but we'll kind of walk through those as well. And what I'll end up doing is, I just try to herd the cats. So these are the cats here, and they'll talk a little bit about each of their different sections. So yeah, Hanjun, why don't you talk about how the core patches are going?
Hi everyone, I'm Hanjun, work as an assignee from Huawei. And yeah, welcome to the most interesting topic, ACPI. Yeah, the ACPI core patches. We do a lot of work on the cleanups and refactoring the ACPI core to prepare the ACPI on ARM64. So it's about 15 patches merged by Raphael. Yeah, so almost the cleanups and the refactoring work are done. And the small minor points need to be addressed in the next version, I think. So for the ARM ACPI core, I sent the V8 patch last week. And in this patch set, we just pardon? Oh, sorry. So in this passage, we just introduce some basic support for the ARM64. And we init the GIC v2 and the SMP using the MADT and the FFT table. And we init the arc timer using the GTDT. So with that changes, you can boot a system with a console driver. Yeah, so basic system. And there's a lot of work on the documentation. So why we need ACPI on ARM server and how it's used. So thanks to Al and Grant. So we tested the patch set on a lot of platforms, from APM, AMD, and KVM, Huawei, and Qualcomm. This patch set works pretty fine. Yeah. And for the document, why we need ACPI, and how it's used on the ARM64 is reviewed by various OEMs and chip vendors. So from AMD, yeah, it's all reviewed by, they replied the email publicly on the mailing list from AMD, Qualcomm, Huawei, and Red Hat, also Red Hat. So I'm still working on the VLAN patch set to try to address some minor comments. And the to-do things here, we need to support the stack, IQ domain, and the framework to init multi-IQ chips. It's for the next steps. Yeah. So what's incoming? And Thomas. Thanks.
Hi, so I would like to update about the 3 topics. It will be GigV3 and its ITS extensions. About SMMU and PCI, I will left Numa to Hanjun. So before I start my status about those bullets, I need to mention that new ACPI tables is coming. It's called IRT. And it's under ARM development. Charles is taking care of that. And what's going on with IRT, it's like we can describe the mapping between the devices and SMMUs and ITS instances. So that table is playing the main role for all these 3 bullets. If you would like to know more details about that tables, I need to forward you to Charles. I've talked to him yesterday. He's happy to answer your questions and share the draft of specification, but specification is coming soon. So yeah, so we've done GigV3 core functionality, I mean the ACPI way of binding, and we also did the ITS. Unfortunately, ITS is not covered by current ACPI spec, but it will be in the next editions. And before we release our code, we also need to create a nice mechanism for multi-gig architecture. Yeah, now a little bit about SMMU. So we've converted that driver to get all ACPI information. And we did it also with IRT tables. And we are also able to map the device's ID to stream ID, which is important for that driver. Now, PCI. So ACPI specs is saying that if you want to make that up and running, we should use MCFG table, but that code is nowadays x86 specific. So obviously we decide to make it shareable across all architectures. I've posted 2 versions of those patches, and I'm about to send another one this week or next. So Bjorn is happy to see this cleanup, so that's fine. Yeah, so PCI host bridge, ACPI host bridge is not the usual driver, it's not the platform one, it's part of ACPI subsystem. So if you want to make it running, we need to provide some calls which get ACPI information and enumerate all the devices on PCI bus. So we did the first initial draft of that driver. We posted. We get, obviously, we get some feedback. Mainly, we shouldn't do that like x86 is doing. It's mainly about keeping private information, especially domain, and that part of that concerns are addressed by the pending PCI patch set. It's called Refine PCI Scan Interfaces and Make Generic PCI Host Bridge by Yang Wang. So we depend on that patches at some point. Yeah, so that's the one of to-do bullets, and second one is getting mconfig patches upstream. Hanjun, would you like to add something about Numa?
Yeah, so just quickly on two things. Numa, there's some patches that have been submitted to the Linaro ACPI mailing list that get Numa working under ACPI, and those have been under review and can be used once the core things are available. And I think you tested it on the Huawei board, right? Yeah. Yeah. Okay. So we know those work. And the other thing is that some of these things are currently covered under the UEFI forum. So we don't have patches for them publicly because we can't do that until the spec is released. We will release as much of that as we possibly can, and we'll probably even push the boundaries. But if you do need to see those patches and are a member of the UEFI forum, just contact me and we have a way to share those with you. So it's not like we want to hide them, but just because of the UEFI rules. Okay, so power management, Ashwin?
Yeah, so real quick, this is the power management contribution to the ACPI alphabet soup. PCC is a platform communication channel. It's a mailbox-like mechanism in ACPI. It's like the lowest level transport for two entities to talk to each other. It's like a shared memory region, essentially. So that's been integrated as a mailbox controller. Initial patchwork is already upstream in 3.19. There's some more patchwork to simplify stuff on its way. Then for CPU performance management, the preferred method right now is CPPC, which is collaborative processor performance control. There's lots of C's and P's there. So the version 4 of that patch set is under review right now. The plan is to make it work with existing governors, like on-demand, interactive, what have you. And on the side, there's also investigation going on for PID-style governors, where you have the driver and the governor inbuilt in one package. So then moving on with CPU idle management, there's a lot of spec work going on, essentially to address shortcomings and make it applicable to ARM-like SoCs. Again, Charles, your man if you want more details on that. And then lastly, device power management, but there's no foreseen infrastructure work expected there. Most of the mechanisms defined in the spec should work. So that's your D-stage, power resources, and PS control methods. So yeah, that's it for ACPI power management. Thanks.
Okay, so Naresh?
Hello, I'm Naresh from KVM, working as an assignee. So most of you people, who doesn't know about LUOS, actually LUOS is a Linux UEFI validation OS, a project which is kicked off by Intel 6 months ago. So I have ported this OS on the ARM64 architecture and posted the first set of patches and got, based on the feedback, I prepared the second set of patches, which is under review. And yes, most of the patches looks okay, and they are going to accept this one. Then CI loop setup is I'm doing with build and baseline team. Yeah, if you need any more information regarding LUOS, you can visit the wiki page and how to build the LUOS and test it on the ARM64 board. You can do that. Okay, thank you.
Hi. Okay, I'm the colleague of L, and I come from Red Hat also. And last year, I working on Lava team, so I can help ACPI team and UEFI team to how to test this ACPI. So when I working on FWTS, I realized it's already being merged into the, our CI loop, and because of Narish, great job from Narish, it's already worked. But when I get involved, I find out we meet two problems for AR64. First is our leg kernel list of where leg kernel have a configuration for strict DEV memory. So kernel not allowed user space to mapping the kernel memory or the acceptor register, or a memory about kernel or the UEFI. The kernel not allow us to remap it. So we need to turn off the stricter DEV memory. And then I find out when I fix this problem, I made another problem is FACS, we have no list table for hardware reduce ACPI table. So we need to ignore it in FWTS. So I made some patch for that. This patch already be merged into FWTS in last year, actually. So right now we have no any problem to run FWTS on AR64, at least on our lag kernel. It's running fine, and we have a lot of tested result in every build, because we merge the FWTS into our CI loop. So thanks Fatih to help us to do this, and you can see a lot of tested results in our CI loop and Lava server. So, yeah. Yes.
Yeah. So just a quick point too is that part of the reason for doing the LoveOS and the FWTS work is making sure that we validate what actually is behaving correctly in ACPI. So the final goal will be to actually run LoveOS, have it run through 2 different test suites. One's called BITS, which is done mostly in the UEFI level. Another one is called FWTS. And have that run through the leg kernel on all of the various platforms that we know we support at this point. So right now it's mostly on the foundation model, but once the hardware is available for Mustang and Seattle and Cavium and and Huawei and all the other ones that are coming along, we'll be able to just run those through the CI loop, just like any other kernel. Okay, so for your eye test this afternoon, so the to-do list. One of the key things that we discovered is that there's a lot of odd little bits and pieces that the x86 world assumes in many strange ways that we haven't really dealt with on the ARM side. So the first one is in the specification itself, there's a way for the operating system to identify itself to the firmware and for the firmware to communicate back to the operating system what it needs from the OS. So that's the very first item, is we got to get that cleared up so that we do not carry along with us all of the legacy stuff that the x86 has with it. So there's some very interesting comments about OSI and the Linux kernel. If you ever want to read them. There's a nice little section on the history of OSI and why you don't want to use it, and it's actually kind of entertaining. But for ARM64, as it turns out, it's not necessary. And as a matter of fact, it's not even really recommended. So there's patches out there to actually deprecate that for ARM64, get rid of it completely, let it be x86 specific like it needs to be, and we can move on. Now, that being said, there is another mechanism called OSC, which stands for Operating System Capabilities, which the OS and the firmware use to communicate to each other who's going to control what. So for example, in low power idle management, one of the things that's necessary is for the firmware to tell the OS or the OS to tell the firmware who's actually in control of that idle management. Right. Well, yeah, and that's the other thing, is that there are a whole bunch of different features of either the firmware or ACPI that are communicated back and forth so that the ACPI code that's being run can optimize its behavior, or so that the OS can optimize its behavior based on the firmware. We need to clarify the process around using that. The specification is not very clear on a lot of details. It tells you how to describe the capabilities, but it doesn't tell you how to communicate what capabilities have been described and how you can share that with other OSs and how you can actually make sure that there's a decent single set of those capabilities across multiple platforms, which is actually okay in the specification, but there does need to be some social engineering that says, here's the bindings for capabilities that we're going to use, and here's the ones that we're going to accept, and here's the ones we're going to ignore. So that process is underway. Okay, second big item on the to-do list was how to handle when the system comes up, how do you handle using device tree versus ACPI? And we've got that fixed in the V8 set of patches based on a lot of discussion with a lot of people. But basically the idea is that you don't want the system to come up and fail if it can avoid failing. So if it, initially we were just going to come up and say, if you don't have a device tree, you're just going to fail. And if you tell us that you're using ACPI and it's not working, we're just going to fail. So now we've got a mechanism where basically it can try device tree, it can try ACPI, and do its best to try to come up and stay running regardless, okay, of the situation. Third thing was UEFI and ACPI test tools. That's where the LoveOS and FWTS stuff has been so critical. FWTS is a test suite for ACPI, but it's really about the only one out there, and it's not terribly extensive at this point. So we're making sure that it works on ARM64. We're making sure that we can actually start putting in place the extensions that we need for ARM64 that test the ARM64 specific things in particular. I guess the other side to that is that this same test suite is also being used by the UEFI forum as the basis for building up an eventual, I don't want to say certification suite, that's a little too strong, but basically a compliance test with ACPI. So it'll be used as the basis for that at some point in the future as well. Next item was really try to set clear expectations on how to use ACPI and what we expect in the kernel and what the kernel can expect of the firmware and what the firmware can expect of the kernel. So we've tried to document as much of that as we possibly can. Whoops. Yes, we're just slowly but surely fading away. So we've tried to document as much of that as we can. Made a bunch of big changes to that. Probably the key thing is we're trying to hold a firmware summit towards the end of March, just after ELC, and actually get all the interested parties together and have them walk through the bits of the documentation and make sure everybody is in complete agreement and understanding of what's there. And if there's things missing, let's find them and fix them. If it's too restrictive, let's fix that. But actually go through that process and try to make sense out of all of that in more detail. Documentation is also part of the patch sets itself, so it's getting reviewed that way. Okay, so item number 5 is where I get to embarrass myself because I haven't done as much work as I would like to do. One of the things we need to do is actually get a bunch of demonstration patches that show how to actually use ACPI as we've built it in the core patches, but actually on real hardware. We have topic branches right now for Juno, not really a server. We have a topic branch for the foundation model, also not really a server. Mustang, guess what, not really a server. And we've got a topic branch for Seattle that I'm in the process of rebasing at this point. And the point of the exercise there is to make sure that we're not doing something completely insane in the way we have to use ACPI, that we can use ACPI as effectively as we can use device tree, and that it makes sense in the kernel. We're not having to bend over backwards and do strange things just to be able to use this other mechanism for describing the hardware. Okay, number 6 is another item very similar to the operating system capabilities, where the specification describes how to do something. It allows you to define device properties, what we often refer to as bindings and device tree. So you've got a key and you've got a value. That's great, that's wonderful. But that's all the spec says at this point. It doesn't say anything about what device properties are defined, what the values mean, all of that sort of thing that we have come to expect in all the bindings for device tree. So we need to get the process clarified for that. There is a basic process for registration of device properties, but how do we make sure that the ones that are registered are ones that make sense? And I think the bottom line is very simple as we go through the kernel, and just like we have with normal bindings, but to be discussed and taken care of. And then the final issue that came up was a fundamental question, is why ACPI? And Grant, out of the kindness of his heart, wrote a very nice little blog post, and that's the URL for it there. We've included that as part of the kernel documentation now, so that you will live in infamy, Grant, at this stage. And that's kind of it at this point. So these are the things that we know we need to address that are not necessarily strictly technical issues. Some of them are just plain social engineering versus computer science. And then we've talked a little bit about some of the other things that are going on as well. So this is kind of where we are. Questions, concerns? Charles.
Bringing it back to the technical, on the timer stuff, for SBSA, you've got generic watchdog and you've got system memory map timer. What are the plans for that?
Okay, so yeah, Fuwei is going to be working on the timer work here. And he's going to get the watchdog timer working and get that implemented as well. So yeah, it's
actually I want to implement the memory map timer in the code patches, but we have got no platform to test, so we left it for the.
Other questions, or? Wow, are we done? Does everybody get a half hour back? That's awesome. Okay, well, thank you very much. This is kind of where we are with things. Any questions at all, feel free to contact us and we'll talk you through it. Okay, thank you.